Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called SVS number 446, Mountain Sudoku by Richard. And here are the rules. We need to apply classic Sudoku rules, where in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. There is a mountain drawn in the grid, shown as gray cells. Its peak is the digit 9 in the central box. The mountain consists of all cells that can be reached from the peak by repeatedly moving to a horizontally or vertically adjacent cell containing a smaller digit. Shaded cells are part of the mountain, and unshaded cells are not. So there's going to be a 9 somewhere in the central box. And the mountain consists of, so anything that's shaded is part of the mountain. And the mountain consists of all cells that can be reached from the peak, so from the 9 that's in the central box, by repeatedly moving to a horizontally or vertically adjacent cell containing a smaller digit. So, for example, say that the 9 was here, and then this was 7, 6, 4, 2. This would be valid because you can get from here to this cell just by going horizontally or vertically, basically through edges. And you can get to here by going through cells that will always decrease. So it's kind of like a reverse thermometer here, if you think about it. And from where the 9 is. We don't know where that is, but we do know that each cell has to be. So it's actually like from the edges to the 9, you have to be a thermometer, essentially. And yeah, I think that's pretty much it. Yeah, I think those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, let's look at the digits that we know have to be. So, we can start sort of working this as thermometers, right? So from here, this essentially has to be bigger than that because it's the only part of the mountain that it shares a cell with. And that's the only way it will increase, I guess, is the possibility. So that means both of these cells. Interesting. So this cell has at minimum, obviously, a 1. This has to be greater than that because it's 2. Because there's no other way that it can go from the mountain. So every part of the mountain is essentially going to be applied to it, right? So you have the 9 somewhere in box 5, and then it must find a way decreasing to get to that cell. Because of that, then it must find a way to decrease to this cell, obviously. So therefore, this cell must be smaller than that. We also know that these cells have to be larger than this cell. So we have 1, 2, 3, and that's guaranteed here. This is 1, 2, 1. These 2 digits are smaller than this one. So this has to be at least a 3. So this is 1 and 3, because this has 2 digits smaller than it, guaranteed. This could go this way or this way, so that's not helpful. This has to go that way, so 1 to 2 at minimum. This has to go that way, 1 to 2. 1 to 2. This could go that way, technically. So, this digit cannot be 9, obviously, because the 9 has to be somewhere in... So 9 cannot be in the mountain sections for the rest, because it has to be able to go down. So where is the 9 in box 2? It has to be here. So 9 cannot be here. Where is the 9 then in box 5? If 9 were any of these boxes, this would be guaranteed to be smaller than it, but it cannot be. So 9 has to be one of these two digits here, which means 9 has to be one of these two digits here. Where 9 cannot be, so 9 has to be here. 9 can't be any other digit in this row because it can't you can't decrease from 9 to 9. So this has to be a 9 here, which means this is not 9 here. So this is the 9 here, which means any of these could be up to 8. So this is 1, 2, 3. You have at least 2 other digits to get to the 9. So that means this is at least, at most 8, at most 7, at most 6. So this is 6, 3 through 6. This is less than that, 2 through 5, 1 through 4. To get to here, 1, 3, 4, 5, 6, 7. So this would be 8 at most, 7 at most, 6 at most, 5 at most, 4 at most. So this is 3 or 4, and this is 1, 2, or 3 here, because it must be less than 3 or 4. So from each cell, there's a certain amount you can get to. Okay, so this cell has to be greater than 1 through 4. 9, 8, 7, 6, 5. So this is 5 at most, which makes this 4 at most. 9, 8, 7, 6, 5. This is 5 at most. So for every cell, there's a certain minimum amount that you can get to. 9, 8, 7, 6, 5, 4, 3. So this is 3, 2, 1, 2, and 3. Okay, 9, 8, 7. Okay, so there's a certain distance away that you know that that's the maximum you can be. So 9, so this is 8. You have 8 as the most here. 7 at the most for the ones that are surrounding that. 6 next to those. 6. 6. This is 5. 5, 5, 5, 5, 5. 5. And then we have 4s. These are 4. This is 3. So 1, 2, 3, 4. This is greater than that. This is 3 or 4. This... Yeah, these two definitely guarantee have to go through here. This could go this way. This digit is bigger than this. So this must be 3 through 8 here. It's bigger than this too, but that's fine. These digits are all bigger than 1 through 4. So this is 2 through 5 here. This 6 eliminates 6 here, so this cannot be 6. This cannot be 5. Oh, these are bigger. They don't have to be 2 through 5. They can be much bigger. Anyways, this is 5, 4, and 3, because this can't be 6 here. This can't be 6 here. Since this can't be 6, this is 5 at best, which means this is 6, 5, 4, and this is 3. We have a 1 through 5 quadruplet, or quintuplet, in column 3, which eliminates 1 through 5 in the rest of the column. This is 7, 8, 9, 7, 8, 9. If 8 were here, that would guarantee that this digit cannot be bigger than this, or the same. It would always have to decrease here. So that's not possible. So this cannot be 8 here. This has to be 7, which forces these to be 6, these to be 5, and this to be 4 at most. Can't be 4, therefore this must be an 8 here. So this has to be an 8. Could it be a 7? No. Because there's no other place in box 5 for the 8 to be, right? Either 8's next to the 9, in which case it does decrease, or it's somewhere else, in which case it doesn't decrease, and therefore would have to be not part of the mountain. But, because this is 8, because this is the only light region here that's not part of the mountain, this has to be the 8, right? Because either 8's here, which would force this to basically be part of the mountain, which it's not. Or 8 is somewhere else, but in that case it has to be part of the light region, because it can't be part of the mountain, because it goes down to go back up to the 8. And that's not possible. So the 8 has to be here. Where is 8 then in box 2? Cannot be here. Can't be either of these, because to get from the 9 to the 8, it has to be one step. So this must be an 8 here. So this is guaranteed to be 8. The 7 has to be one of these two to be next to the 8. So these are the values that can be there at most. 8 can't be here, but 8 could be here. 9 is one of these two, obviously. So 9 cannot be here. Where's 9 in box 9? It has to be there, which means 9 cannot be here or here. Where's the 9 in column 7? It has to be there. So 9 cannot be here. 9 can't be here in box 1. 9 has to be there. 9's one of those two. 9's one of those two. This can't be 8 anymore because of the 8 in the row. Oh, this can't be 5 here. Where's the 5 in column 3? Also, we have a 1, 2, 3, 4 quadruplet in box 1. So the rest is 6, 7, 8. This can't be 8 here, so this must be 8 here. This has to be a 6, 7 pair, which eliminates 6 and 7 in the rest of the row. So it can be 9, 8, 5. And then this could be 9, 7, 6, also 5 as a possibility. This can't be 6. This could be 5 at best, but this could be 9, 8, 7, 6, 5 that way. This has to be 1 through 5 here. To be down, where's the 7 in box 2? To be on the mountain, it has to find a way somewhere to be decreasing continuously to the 7. And it can't be here, so it has to be here. So this is 7, which means this can't be 7. This is at most 6 to 5. 5 to 4. 5 to 4. Where's the 7 in box 5? It has to be here. Because there's no other place for it to satisfy the mountain and still be in the box. So this is 7. Where's 5 in column 3? It has to be here, because it can't be here, it can't be any of these, so this has to be 5 here. Well, to be continuously decreasing, this is not going to be bigger. It has to be less than this, and this, or this, or this. But either way, this is going to be 4 at most. So it has to be 6 here. So this is 6, which means this cannot be 6 here. We need an 8 somewhere on this in row 4 on the mountain. So that means it has to directly go to from the 8, from the 9. So this is 8. This can't be 7. We have, this is 4 at most. So this is 2, 3, 4. This technically, okay, so this to get here, this must be smaller than this. So it's 1, 2, 3. This cannot be 5. This can't be 5. Where is the 5 then in row 3. It has to be one of these two. So this can't be 5 here. This is 4 at best. This cell is going to be less than either that 4 or that 4, so it can't be 4. This is 3, which forces this to be a 1-2 pair. Therefore, this must be 4 here because of the 1-2 pair and the 3 in the box. So this is 4. 5 is one of these two because this can't be 5. It either goes to here, so this is 1, 2, or 3, and this is less than one of these two, which would have to be 1, 2, or 3. So this is 1 or 2 here. This can't be 4 anymore. This can't be 3. This 1, 2 matches this 1, 2. This can't be 6, so this has to be at most 5, which means this is at most 4. This can't be 7 or 8. This could still go this way to be 4. So that's fine. 5, 4, 5, 4. So then this would be 3 at best. So this is 1, 2, or 3. This is less than that. This could be 1 through 5. 1 through 5. 1 through 4. This is 1 through 4. This is 1 through 5. Hold up. So can it go this way? I think the answer to that is no. I think it has to go this way. Right? If we try going this way, so 1, 2, 3, 4, the problem is this is not going to be bigger. So it has to go through this way, which means this is 4 or 5. It has to go through this way, which means this is 5 or 6. It has to go this way, which is 6 or 7. It could sort of go around. We don't know. This is 1 through 6. Okay, so then where is the 7 in column 7? It has to be here because there's no other place for it. This is 1, 2, 4, 5, 6. This is 1 through 5. Can't be 5 though. There's a 5 in the row. This could be 1 through 6 without the 5. This is 1 through 4. 1, 2, and 4 here, potentially. So one of these is a 6. Okay. This is 1 through 5, 1 through 6 completely. This actually 7 eliminates 7 here, so this is 9, which means this cannot be 9 here. This is a 7, 8 pair. This is 1 through 5 here. We have a 1 through 4 quadruplet in row 4, which eliminates 1 through 4 in the rest of the row. This can't be 1 through 4. This is 5. That's 6. That leaves the remaining digits of 7, 8, 9. 9 cannot be here, so this is 9 here. That forces this to be a 7, 8 pair. We know 4 is one of these two, so 4 cannot be here. We know 3 is one of these three, so 3 cannot be here. So this is 5 with 1 or 2. So this can't be 5 or 6. We have 1, 2, 3, 4 here. This can't be 1. It has to be greater than 2 digits, so it's at least 3 or 4 here. We know 1 is one of these two. Okay. This is the same digit as that. Six can't be here. 6 can't be here. 6 can't be on the mountain, so 6 is one of these two digits here, which means in row 8, 6 has to be one of these two digits here. This digit is greater than 2 digits, so it's at least 3, but it can't be 3. It's 4, 5, 6, or 8 here. It cannot be 5 because of 5 in the column. This digit is greater than a 5. So it cannot be 6. It's 7, 8, or 9 here. digits greater than 2 digits, and one of them has to be 3, so this is 4, 6, 7, 8, 9 as possibilities. This can't be 4. If this is 4, that would force this to be 3. And therefore, this would be part of the mountain, so this can't be 4. Remaining digits in box 4. We have 1 through 6. Obviously 5 can't be here. This can't be 1. This can't be 1. Because if they were both... And this has to be greater than that digit, so it can't be 2. Because it has... It would be part of the mountain otherwise. Hmm. 5 could go from here. 7, 6, 5, right? Hmm. 8 and 7 both have to be in column 4 here. That means the remaining digits in column 5 are 1 through 6 and 9. But this can't be 1, obviously, because that would guarantee... This is next to 2 unique digits on the mountain, so it has to be at least 3 then. But this digit is 2 smaller than this. So if this was 3, this would have to be at least 2 smaller than this, which would be make that a 4. So that's not possible to be 3. This could be 2 still. Okay. If this were 3, that would force us to be a 1, 2, 1, 2 pair in box 4, which would eliminate 1, 2, and 3 here, so that would be 4, and therefore the 3 would be smaller than the 4 and would be part of the mountain. So it cannot be 3. You know, one of these is a 6. We don't know which. This digit is greater than 2 at least. So this is 3, 4, 5, 7, 8 as possibilities. Where is... 1 could actually be here. Because it would have to go up and then go back to 1 there. That could be the case. Where is the 1 in column 7? It has to be one of these 2 cells because it can't be any of these 3 because they're all greater than this cell. So 1 has to be here, which means this can't be 1. This is 2, which forces this to be 3. That eliminates 3 in the rest of the region. This can't be 2 or 3. It's a 1, 5 pair, which eliminates 1 and 5 in the rest of the box. So this is 2, 3, 4, 6. 3 has to be coming down from something, so this must be 8, 4, 3, 2, because it can't go this way because this is increasing from the 2 to the 3. So this is a 4, which means this can't be 4. This is 3. This can't be 2 or 3. It's 1. This can't be 1 or 3. It's 2, which eliminates 2 here, so that's 1. No 1 or 4 here. This digit must be smaller than that, so this is 3. This is 2, which eliminates 2 and 3 here. This cannot be 2. This is a 1, 5 pair. This digit has to be 1. So it cannot be 1 here. This is 2, 3, 4 as a triplet. This can't be 6 because of 6 in the column. 1 is one of these. This cannot be 2. So 2 and 3 have to be here because it can't be here in column 7. So this must be 2, which forces this to be a 3. This has to increase from there. This can't be 4 because of 4 in the column. This can't be 4 because of 4 in the column. Um, 3 eliminates 3 here. So we have 1, 2, 2, 4. We have a 1, 5 pair in column 4, which eliminates 1 and 5 in the rest of the column. So none of these could be 1. This can't be 2 because of 2 in the row. So we know 1 then has to be one of these 2 on the mountain, because 1 and 5 cannot be here. Therefore, this is what? 2, 3, 4. No 1, 5, no 6, 7, or 8. This can't be 2 because of 2 in the row. Hmm. Remaining digits in row 1. No 2 or 3. It could be 1, 4, 6, or 7. Well, this can't be 1 or 4. So this is 6 or 7. This can't be 1 because of 1 in the column. This digit cannot be 3, 7, 1, 2, 3, 7, 9. So it could be 4, 5, 6, or 8 here. This can't be 6 because of 6 in the row. One of these two is 6. We already knew that. This is next to 2 unique digits, but that's fine. This 1 eliminates 1 here, so this is 2, which makes this 1. So this cannot be 1 here. Where's the 1 in column 7? It has to be here. So that's 1. These can't be 2 anymore. One of these has to be 3. We know 2 has to be one of these 2 digits here. Um, that doesn't seem quite right. I think I might have messed up a little bit. But anyways, yeah, this is... I feel like I messed up a little bit. Let me look at some parts. I'm looking at this section. I don't necessarily know if that's correct. Actually, it does have to be. Never mind. Never mind. It's because, okay, so the reasoning why I think this is correct is, what I was thinking was that this could have been a 5 here, right? But the problem with that is that where is the 5 in box 6, right? Maybe. Maybe the 5 could have been there. I think I did make a bad assumption. Let's go back. Let's see how far back it is. Oh boy, this is going to be a while. Okay, so before we have the 5. Yeah. This could actually be 5 here. This does not have to be 5 here, but I mean, this cannot be 5 here because it's less than one of these. But this could be 5 and that could be 4. Yeah, that's a bad mistake. Okay. So then, right. Yeah, because I did make this 1, 2, 3, 4, right? But this could be 7, 6, 5 that way, and then that's where I messed up. 7, 6, 5. This could be 4. Could be 5 and 4, but that's it. So so this is a 1 through 5 here. That forces this. So this has to be, this digit is 2 less than this digit. So it has to be at most 5. So then we have a 1 through 5 quintuplet in row 6, which eliminates 1 through 5 in the rest of the row. So this is 6. This can't be 9. So this is all the same. This can't be 6 here, but this assumption was incorrect. Because it could go from 6 to 5 here, and that's fine. Anyways, I don't know how much that changes. Maybe it changes a decent amount. This is 6. This digit is greater than both of these, so this cannot be 5. This would be then 3, 4, 5 here. Okay, so that is, yeah. I was saying one thing that was basically problematic. Anyways, this is still the same. These can't be 1 because it must go through this path. It cannot go 1, 2, 3, 4, 5 because then this is limited here, right? So it has to go through this path. So 1 has to be here, which means this can't be 1. That's 2 and 1, not 1, 2 and 3 here. So this can't be 2 and 3 here. Where's the 2 in column 7? It has to be here. Whereas the 3 then in column 7, it must be here. So 2 and 3, which means this is less than 2, this is 1. So none of these could be 1 here. Where's the 1 in box 6? It has to be here. So this is 1. This cannot increase going this way. It must increase going that way. So this is a 4. This can't be 3 or 4, so this is 2. This can't be 2 or 4. This can't be 2 or 4, and we have a 3, 5 pair here, right? This can't be 1 or 4. Again, this must be greater than that, so this is 3, this is 2, which forces this to be 1. That eliminates 1 here, so it's 2 and 1. So these are all the same. This was essentially the problem here, right? This could actually be 3, and that would be fine. This could be 5, and that would be fine. Same with this one. These can't be 1 anymore. That requires this then to be a 4, 6 pair, which eliminates 4 and 6 in the rest of the row. 1 can't be here, 1 can't be here. Where is the 1 in column 7? It has to be here, which eliminates 1 and 2 here. This is 3, 4, and 6. This can't be 2 or 3. It's a 1, 5 pair. These can't be 3 anymore. So then we don't have the 1, 5 pair here. Okay. Remaining digits in box 3. We have 4, 5, 6, 7, 8. 4 cannot be here. No 8 here. No 5 here. So 7 is one of these two. 7 can't be here. 3 eliminates 3 here, so this is 5. Okay, so then that's 3. Okay, so then that's the same. Okay, well. This is less than one of these two, so this has to be 2 or 3. Okay, well, we come up to the same place. But we did have poor logic there, so that's why I had to fix that. This can't be 9. This is a 7, 8 pair. Remaining digits in column 4. We have 2, 3, 4. No 1, 5. No 6, 7, 8. Okay, so this can't be 3. No 2 here. Remaining digits in column 5 are 1 through 6 with 9. But this can't be 6 because of 6 in the row, and these can't be 1 because they would be greater than this, or they would be less than this cell, which would force it to be on the mountain. This can't be 2. This can't be 3 because this cell is 2 less than this one, at least. Wait, is that the case? That's not the case. It could be 1, 4 here, and this is 2, and then that's 3. And then this goes this way, right? So, remaining, this 5 eliminates 5 here. Remaining digits in column 8 are 6 through 9. This can't be 6 because of 6 in the row. This can't be 2 because of 2 in the row here. So one of these is a 1 guaranteed here. Remaining digits in column 9. 4, 5, 6, 7, 8. This can't be 6. This can't be 6 because one of these two is a 6. So 6 is one of those two. Okay. This is all done. So to get to the 1, 9, 7, 6, 5, 4, 3, 1, 9, 7, 6, 5, 4, 3, 2, 9, 7, 6, 5, 3, 2, 9, 8, 7, 9, 8, 4, 3, 2, 1, or just 9, 8, 4, 1, 9, 8, 4, 2, 9, 8, 7, 6, 5, 9, 8, 7, 6, 1 of 4, 5, 3, 2, 1. If 3 is here, that's still fun because this could be 4. And then this would be 6. So it could be 9, 8, 7, 6, 4, 3. And then 1. If this is 1... Okay, this can't be 1. If this was 1, this would be 2 and 4. But you can't get to the 4 correctly because that would be 1. Right, so this digit has to be less than one of these two. And if this is 1, it's not less than that. It's not less than the 3 as a 4. So this has to be 2, which forces this to be 1. Right, if this is 4, it's going to be greater than both of these, which means it cannot be from the peak going down all the way to the 4. So this must be 2, this is 1, which means eliminates 2 and 1 in the rest of the box. So this is 3 or 4. This can't be 2. So we have a 3, 4, 3, 4 pair in column 6, which eliminates 3 and 4 in the rest of the column. So this can't be 3 or 4. This is 6. This can't be 3 or 4 or 6. So this is 5, which makes this 1, which makes this 5. That eliminates 5 in the rest of the box. Where is 6 then? Can't be here anymore. Can't be here, can't be here, so it must be here. Where does that leave 9? 9 has to be here, which means this can't be 9 anymore. So this is 9. Where does that leave 6 in row 8? It has to be here. So this cannot be 9. We have a 3, 4, 5, 7, 8 quintuplet in row 7, which eliminates 3, 4, 5, 7, 8 in the rest of the row. This has to be 1, 2. This can't be 1 because of 1 in the column, so this is 2. This is 1. I think we have 1 eliminates 1 here, so this is 5. That's 1. We have 9 ones now, right? 1, 2, 3, 4, 5, 6. We should have... Oh, we don't have 9 twos. Okay, remaining digits in rows 8 are 4, 5, 7, 8. We need a 5. 5 can't be here because of 5 in the column. 5 can't be either of these because 5 is in the column. So 5 has to be here. Therefore, this is 4, 7, and 8. Cannot be 7 or 8 because of the 7, 8 pair in the box. So this is 4, which makes this not 4. This is 6, that's 4. 6 eliminates 6 here, so it's 7 and 6. 7 eliminates 7 here, so it's 8 and 7. That leaves this digit as a 3 and this digit as a 9. So we have 3 in the corner. We can't have a 3 here anymore. This can't be 5. Okay. So this can't be 6. If this were a 4, it would be next to a 3, a 1, and a 2 on the mountain, which it's all greater than. So that would not work. So this cannot be 4. This has to be 2. So this is 2, this is 4, that's 3. The 4 eliminates 4 here, so it's 5, which makes this 4, so this can't be 4. That's 3, which makes that 4. This can no longer be 2 or 4, so this is 3, which forces this to be 2. This can't be 3 here, and it can't be 4 because of 4 in the row. So we have a 7-8 pair in row 7, which eliminates 7, 8 in the rest of the row, and this can't be 4, so this is 5. This can't be 4. Where is the 4 in box 3? It has to be here. 6 eliminates 6 here, so it's 7, which makes this a 6-8 pair. 7 eliminates 7 here, so it's 8, which eliminates 8 here, so it's 6, which forces this to be 8. This can't be 4 or 8, it's 7, which eliminates 7 here, so it's 8 and 7. This can't be 7 or 8, it's 4. This can't be 4 or 7, it's 8. That forces this to be a 7. And that's a solution. Let's just double check. 9 to every part of the mountain. So 9, 7, 6, 5, 4, 3, 1. 9, 8, 7, 6, 5, 4, 3, 2. 9, 7, 6, 5, 4, 3, 2. Obviously, these are all satisfied. To the 1, 9, 8, 5, 1. 9, 8, 5, 4, 2. 9, 8, 5, 4, 3. 9, 8, 7. 9, 8, 6. 9, 8, 6, 7. 7, 6, 1. 9, 8, 7, 5. 9, 7, 6, 5, 3, 1. 9, 7, we can go this way too. 9, 1. 9, 8, 7, 6, 4, 2. 9, 8, 7, 6, 4, 3, 2, 1. 9, 8, 7, 6, 4, 3, 2, 1. 9, 8, 7, 6, 5. 9, 8, 7, 2. 9, 8, 4. 9, 8, 4, 3. 9, 8, 4, 3, 2, 1. So that satisfies that. And then off the cells that share an edge with the mountain must just be greater than that edge. 8 is greater than 1 and 2. 9 is greater than 1. 9 is greater than 2, 2, 3. 6 is greater than 1, 4, 3. 7 is greater than 1. 6 is greater than 5 and 3. 8 is greater than 2. 9 is greater than 8, 5, and 3. 6 is greater than 2. 4 is greater than 3. 9 is greater than 5, 5, 1. 8 is greater than 7, 5, 2, and 1. 3 is greater than 2 and 1. 9 is greater than 5. 6 is greater than 1. Did I do 7? 7 is greater than 1, obviously. 6 is greater than 1. 7 is greater than 3. 9 is greater than 2, 3, 1. 8 is greater than 4 and 5. 8 is greater than 1. 6 is greater than 1. 5 is greater than 2 and 2. 9 is greater than 3. And 7 is greater than 1. So, very cool, actually. I like the rule set a lot. That's a very interesting rule set. I made one bad assumption that I spotted. There might have been another bad assumption that I made, but because this is kind of tricky. But the idea behind it is actually kind of fascinating. It's like a reverse thermometer in a sense. So it's kind of cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.